Hi guys, my name is Ron Wills, and today I'm going to be talking about the type of tools you could use for your air conditioner work whenever you work in an HVAC field. I'm a residential AC homeowner, and I'm just giving some advice for regular folks out there who own a home and have a AC split system with an air conditioning system over here and the air handler in the attic, for example. So basically what I ran into is a problem with my AC freezing up, specifically the low pressure side of it, and the evaporator handler was freezing up. And what I did is I ended up replacing the capacitor. I have a video for that in another video that I posted, and feel free to check it out. But that didn't help. It did help though from the standpoint of having the motor, the airflow, improving the airflow and having the motor blow, but it wasn't actually, it was still freezing up, especially when the temperature went up. When it got a little hotter, that's when it started freezing up. So now I have this this particular umbrella, beach umbrella, set up specifically to make it easier for me to work on this field. I just gotta mount it a bit. Okay, so anyway, the bottom line is it's a bit hot outside, so what I'm gonna do is I'm actually gonna work on this AC system and show you how what I'm running into in a typical HVAC work. In this particular case, the work happens to be in my house, and yeah, so the umbrella is helping me over here to hide from the sun. I got the gauges over here installed as well. I'm just chilling over here. But yeah, so the problem that I ran into, the first problem I ran into in HVAC field was actually taking this little piece out, and this comes out of the electrical box, and as you can see, there's a little wasp over there. So I have this hot shot wasp hornet thing to actually kill it, but yeah, and gloves and glasses for safety, especially when handling refrigerant. But yeah, so the first thing I actually did is I wasn't sure if my compressor was running, so what I did is I did a little schematic over here, and as you can see, I have red to blue equals 4.3 ohms, blue to black 3.5, black to red equals 1.4. And what I did is I drew this the schematic where from common to start, and to R, basically, think of it this way. The whole purpose of me drawing the schematic is because I wasn't really sure what's going on, like where the wires are hooked up, and plugged the capacitor, but the capacitor is all screwed up, as you can see over here. You can't really see any markings on it. You can't really tell where it's supposed to go, which cable is supposed to go. So sometimes you just gotta go back to the source, and in this particular, the source is the horse's mouth, which is the compressor itself. So if you look closely inside the compressor, I could actually go ahead and take this umbrella and have some sun going into it. I don't know if you see the markings, but anyway, the bottom line is it actually on a compressor, it shows you what CR and S is and which terminal it's supposed to go to. This is a contactor that I have with L1, L2, and T1 and T2 connections. L1 and L2 is where the 240 volts coming in. So if you were to actually go ahead and put the multimeter over here next to the L1, the red one and the black one, you'll get yourself a 240 volts. And this little bad boy over here is basically a way for you to turn on the compressor from here directly in the fan. So if I was to actually press it, remember I have the power turned off, it would just go ahead and turn on the fan, and you would use this in certain cases when troubleshooting the system. But right now my main concern is when I ohmed out the compressor, I realized that everything is good, meaning the distance of the segment SC, think of geometry when you're dealing with geometry. The segment SC plus the segment of CR equals the total distance between S and R. So that's essentially how the resistance works. So you have, in my particular case, I have SR equals 4.3 ohms, which translates in the world, in my world of wires, coloring. Essentially there's three color wires that's coming out, right? There's red, blue, and black. And if you look, and those red, blue, and black corresponds to C, S, and R. But how do they correspond to? I specifically drew it over here. I said, okay, S equals blue, and equals Herm. Herm is the compressor part, and that is supposed to go to L2. Common equals black, and it's supposed to go to L1. The funny part is though, what is shown on the compressor is not necessarily, that's not how things were plugged in on my world. So I'm a bit confused. But anyway, the bottom line is, to be less confused, what you want to do is you definitely want to rely on resistance to figure out what could be the S and what could be the R. So when I measured from red to blue, I got myself 4.3. That, and from black to red 1.4 ohms, and from blue to black 3.3 ohms. So what that means is, as you can see, the biggest number here is 4.3, essentially the approximate sum of the resistance. It's essentially, if you add 1.4 and 3.3, well, you get yourself what, 4.7. That's relatively close. So as long as it's relatively approximately close to 4.3, we should be all set. And that's essentially, when you're checking the ohms, you're essentially checking using this multimeter tool, and basically all you do is just adjust this bad boy to the ohms, right? And then you use those two wires to go ahead, two connectors to pretty much go ahead and just unplug one connector to one, to black wire, red to blue. So have one connector connected to red wire, another one to blue, and blue to black, and black to red, right? And you just, that's how you verify the capacitance, and it wouldn't make actual sound. So if right now I have a capacitor over here, but essentially what I ended up doing is I took out those wires out of the capacitor, and I ended up and just, tested out the continuity. So let me go ahead and show you how I do that.